Well, hello, and thank you for your interest in Eagle. I want to keep this video pretty short, but I thought it might be useful to run through a little bit about what's going on with our demo. So let's do that. Let's actually click on Run. Okay, so what you have here is the Eagle landing page, and the first thing to say is we've written our GUI in HTML code. So we're rendering that code with a web browser, but everything is remaining local. So even though in retrospect we use some disturbing terminology such as upload data, nothing's actually being uploaded onto the internet. Everything is remaining local. You can use Eagle without any internet connection at all. So don't worry, your data's not going anywhere. The way we think about our GUI data is we break it up into different parts. So we have the marker data, we've got the phenotypic data, and then we have a couple of optional data sets depending upon your circumstances. So we have the map, and you may or may not have that. It's hard to believe that you wouldn't have a map in this day and age, but you may or may not have that. And then there's this thing called this Z matrix, and I won't go into it here, but it's something that's common in plant studies where you have multiple measurements per plant. Okay, so what I'll do is I'll just walk you through each of the steps, and the steps are here in this navigation bar. So if you go to the top, click on Read Genotypes, it will take you to a page that's pretty indicative of all the pages. Like all the pages pretty much look like this. For each of these options. And what we do is on the left hand panel we have the steps you need to walk through, and in the right, even though there's nothing here at the moment, what will happen is once we upload the data you'll start to see information appear in this right hand panel. The other thing that might be of use to know is if you're stuck at any point, we do have help in various forms. So we do have this icon over here for help, but we do have little pop-ups as well to try and help you on your way that has hopefully some fairly useful information for you. So let's upload the marker data, and we've tried to keep things as simple as possible. In terms of different types of marker data that Eagle can handle, it can handle two types. It can handle p-link PED files, or it can handle just plain space separated text files. So what we've put up on our server is just a p-link PED file. So in this first choice you can just leave it as p-link. You can just leave the memory as it is. Like there's no way you need 8 gigabytes of memory to analyze this data, such a small data set, but just leave it as it is, and then come along and to this third step, and that is select the file. So there's two ways of doing this. One is if you click on select file, it will start a browser for you, or if you have problems with that, and we have had some problems with the browser on some systems, so as a fail safe or a backup, you can actually just put the full path name down here in this dialog box. But let's run select file, and what I will do is starts the file browser, and just come along and click on genodemo.ped, which is or contains the SNP genotype data. Click select, and then just come down here into step 4 and upload the file, even though, as I said before, nothing's actually been uploaded onto the internet. It's just being uploaded into the system. Click on that, and then you have a bunch of mark or summary information that appears here on the right. So they happened all very quickly because it's such a small data file. But in practice, if you have very large data files, this might take a bit of time. But what you'll see here is down here, like it's too fast for you to see, is a little dialog box that tells you something is happening under the hood. Okay, so with that done, let's actually load in the phenotypic data. So again, we've set things up to involve as little interaction from you as possible. So the phenotypic file does contain column names. So in step 1 we just leave this as yes. It is a space separated file, so you can leave it as no. There's no missing data, so you don't need to put a code in here for the missing data. What you do need to do though is in step 4 is to select or tell Eagle what the name of the file is. So just come along and click on select file, and let's go along here and click on phenodemo.dat, select, and what you'll see is the full path and name of the file in the dialog box, or you could do that manually if you wanted to, and then go upload file, and there's a bunch of summary information that appears that probably no one looks at unless there's a problem appearing here in the right hand panel. Okay, so let's now just zip across to read map. Again, leave everything as it is. It's just step 3, come along, select File, Map Demo.dat, go select, then upload the file, and there's some information. So let's go along now to something a little bit more interesting, that is analyze the data. So this is the page where all the action takes place, and that is you get to choose the name of the file, get to choose the name of the trait. If you've got fixed effects, you get to choose what fixed effects are going in the analysis, and you come along, choose a number of CPU, and you choose this mysterious gamma value. So with the phenotypic data, you don't have to have a separate file for each trait that you have. You can have it all in a single file. You can have all your phenotypic data, so all your traits, all your fixed effects, all in a single file, and you just come along and choose what you want, or you tell Eagle what you want in this first step. So if I click on this box, what you'll see is the choice of different traits I might have for my analysis. Like, we haven't been very imaginative in that we just have trait 1 and trait 2 as our 2 core traits, but let's leave it as trait 1. And then in this second step, what you'll see are other options that you could have potentially for your fixed effects. So Eagle does have trait 2 in here in the list because it doesn't know by the name alone whether it's a trait or fixed effects, so it just puts anything that's available going in there. But let's just pick PC1 and PC2, and what you'll see is the fixed effect part of the model starts to get built up here, so it's telling you what's going on. Let's leave the number of CPU as 1 because we do only have 1 CPU on our server available to our session. And then you come along to step 4, and there's 2 choices here. One is to set this gamma value manually or to set it automatically, and this deserves a little bit of explanation. So Eagle builds models, but in building the model you have to have some way of deciding which model's better than the others. And the way we've decided to do that is using what's called an extended BIC. Now with this extended BIC, for those of you kind of familiar with BIC, it's BIC with a bit of a regularization parameter tacked on the end of it. And the regularization parameter is controlled by this gamma value. So gamma value is close, like the gamma value ranges from 0 to 1. Gamma value is close to 1 means that the analysis will be quite conservative. So it strongly guards against false positives. Or if your values are closer to 0, then the analysis is much less conservative, which means that you have a much greater chance of finding true positives, but also you have a much greater chance of making a mistake and finding false positives. So let's leave it as it is at the moment, where it's set manually. And what you'll see here is its default setting is set to 1, which is its most conservative setting. So we're just going to do, if you like, a preliminary analysis of the data. It's going to be very quick. Let's click on perform analysis, and it's going to be very conservative in the sense that it's guarding against false positives. And as soon as you click on that, you'll start to see output appearing on the right hand side. And if you scroll right towards the bottom, it did find 2 regions of interest, and you just take note here the gamma value for the model was set to 1. So that doesn't look very nice, I agree. So what you do is come along to findings and click on findings, and it just gives you a bit of a prettier presentation of the results. And what you'll see here is in this first table are just the parameter settings, reminding you of what trait you chose and the fixed effects and the gamma value. And then you'll have here the results. So it found 2 SNP that are in strong association with the trait, and here's the chromosome number and the position for those SNPs. So that's all well and good, but let's suppose you change your mind and you want to do a different analysis. Then you don't need to reread the genotype and the phenotype data. You can leave it all as it is. Just come back to the analysis page and make your choices. So let's suppose now, instead of doing our analysis manually, which is the, if you like, the most conservative setting, in some sense a preliminary analysis of the data, let's do it where Eagle chooses that gamma value according to a certain level or a certain false positive rate. So what we have here is, like, ideally it'd be really nice if we had an analytical approach that allow us for certain false or for desired false positive rate to give us the gamma value, but there isn't. So what we've done is we've done the next best thing, and we actually do this empirically. So what we do is we want to set a gamma value for a desired level or for desired false positive rate, and we're doing that through permutation. So there's 2 things here that you get to choose in terms of doing this or allowing Eagle to do things automatically. First of all, you get to decide what that false positive rate is going to be. And in this case, we've tried to set the default value to something sensible, and we've just have it set at 5%, but you can go anywhere from 1% right up to 50%. Like, I don't know why you'd want a false positive rate of 50%, but we've allowed you to go right up to that value if you want. And also we have this second option of specifying the number of replicates. Now, one thing about this, one of the nice things about this is because the fixed effect part of the model is not changing across all the replicates, we're able to make some pretty substantial computational cost savings in our algorithm. So it's not going to take 100 times longer because in essence we're doing 100 different separate analyses. That's not how this works. But there is an extra computational cost to this. So it will take on average about 5-6 times long choosing this set automatic option as opposed to doing it manually. But I think the cost is well worth it, because what you're able to do is you're able to actually fine tune the analysis to a certain false positive rate, which I think in most cases people are going to want to do. So let's just leave this at their 2 default settings and perform the analysis, and what will happen is it's going to take a little bit longer now because it's doing more under the hood. Now don't worry, the page hasn't frozen. What you have here is this little dialog box that shows you that something has happened. Like, it takes a little bit of time to find that gamma value, but once it's done that, it will then launch into the analysis that we did before when we're setting it manually, except now what's happening is it's chosen a different gamma value. It's chosen a gamma value that will give a false positive rate of 5% for the analysis. Now, because we have such large effects for the analysis, it's only a toy data set. In actual fact, there were only 2 SNP that I generated. To be in a actually maybe that's not true. Maybe there were a few more, but these were quite large effects. So even by us downgrading the size of the gamma, so making it less conservative, it still really only found the 2 largest effects in this case. Okay, so if we go into findings, what you'll see here now is that the gamma value has changed. So it's mirroring the fact that we have a new gamma value and things have just updated themselves dynamically. The other thing I should mention is you've got this strange symbol here that looks like 3 fingers. In actual fact, it's meant to be a histogram, but you've got these 3 symbols here. And what this does, if you click on this, it just gives you some additional information. So it takes a little bit of time to calculate, but it gives you some information such as the effect sizes and the significance of those effects in the fixed effect part of the model, and also it tells you how much variation is being explained by those SNPs that you found in the model. So before I go, one other thing is, if you're really stuck, just come along, click on help, and what this will do is it'll take you back to the Eagle website where there's a whole lot of information. And thank you very much. Hopefully that's been useful to you. If you have any questions, by all means email us and we'll go from there. So thank you. Bye.